All right, we got the big finish for test 2 coming up. And off screen, we talked about your retrosynthetic analysis for your next test. And the end of that discussion was, it will be a Malonic ester synthesis. I will say no more. So let's go through the forward version of the Malonic ester synthesis. And then over the weekend, you can do the retro version. And on Monday, I'm sure it'll be a better review day then. So you'll be told on the exam, you're allowed to start with alcohols or diols of 5 carbons or fewer. And look at what I'm starting with here. A diol with 3 carbons. So that would be a thing you could just write down on the page and say, I'm going to start with that. And you got to make it into an ester. You can't do a Malonic ester synthesis unless you have a Malonic ester first. And that's the third molecule, isn't it? So what do you have to do first to the diol to make it into a dicarboxylic acid? Oh my. What chemicals do we like? LDA would take the H's off the 2 O's and the story would be over. LDA is a base. This is an oxidation. How do I know? The number of bonds to oxygen changed. That's always oxidation. So oxidation, and I need the chemical that oxidizes alcohols, the fullest that can be oxidized. Which one is that? There's 2. She likes CrO3, H2SO4, aqueous. You could put, instead of CrO3, K2Cr2O7, but you still need H2SO4AQ. How do we make esters? And I really hope nobody in this room thinks that stands for the element praseodymium. Wrong course, people. In organic chemistry, the short form PR. She's writing it on the periodic table. Okay, it's propyl, right? It's right after cerium. Yeah. Okay, but it's not relevant, so I shouldn't have brought it up. Propyl. So I need to make propyl esters, correct? I mean, you could write PROH, but at least show me you know what a propyl is, you know? I would accept HOPR. That's fine. H2SO4, you like that one? You want to show off? You can put some DST in there. Don't get points for it. That's why I put it outside the box. Yes, you want to make sure this reaction goes to its best equilibrium outcome. You should use a large excess of the alcohol, shouldn't you? I wouldn't grade that either. As long as I see that alcohol in there and sulfuric acid, or hot, you can use hot, I will be happy. And then we're going to do synthesis times 2. You do realize there's 2 alpha H's, alpha to 2 carbonyls, right? This is the beauty of the Malonic ester synthesis. Those H's are easy to take off because of their pKa being 10. So it makes a very easy nucleophile. And what we're doing here, KOH takes an H off, benzyl bromide is this one, isn't it? Br. And yes, you're going to get more opportunities to remind me you know what benzyl is on every test. I could have been nasty and said you will be losing points every time you don't know what benzyl is. If you still think benzyl has a bromine attached to the phenyl, you're wrong. 1 more carbon. And so there's nothing going on here. This should have been a blank. I apologize. And that was supposed to be a blank. You guys, just put a box around it. Don't erase it. Just put a box around it. You got the answer right now. You had the answer there. Okay? You don't have to copy this. OPR, carbonyl, OPR. So the first two steps do this, correct? And then step 3 takes the second H off, and step 4 puts an isobutyl on there. So you did 2 syntheses. That's why it says ×2 up there. There's your isobutyl. And you already have that written there. Saponification, acidification, decarboxylation. Oh, there's my other wrap finish there for the nation. That also sounds pretty good. I like the with the tautomerization better though. You want to know the short form result? Because this is not about mechanisms here, right? The short form result is you're going to saponify both esters. And in the end, you're just going to, here's your CO2. Okay? Copy everything else except the PR. It's now an H. And you're going down and you get a benzyl and ibu. And this is how you know you've been, well, don't go crazy like that. In this box is acetic acid. So when you do a retro on this, you would see that in your target, there was acetic acid. Therefore, you know you had to do the malonic ester synthesis because it always makes an acetic acid with 2 new R groups alpha. Isn't that exactly what's in this box? The acetic acid's in the red box. The other parts are 2 new R groups attached to acetic acid's alpha position. And that is the calling card for a malonic ester synthesis. And then I need to know how to convert a carboxylic acid to a derivative of a carboxylic acid. Your target molecule will be a derivative of a carboxylic acid, which means your first target's really a carboxylic acid. We just drew it. Okay? And we're supposed to know how to interconvert all derivatives of carboxylic acid. That is the whole point of chapter 18. You should be able to go from any derivative to another derivative. As you're studying, keep those words in mind. Because right now, I don't think you're comfortable with it yet. Okay? Because you haven't reviewed yet. And now I've got to first put a better leaving group up there on the carbonyl. What is the best way to convert an OH leaving group to, well, OH to a better leaving group? She likes acid halide, and I like that a lot. And that's always SOCl2 and pyridine. And then you can react it with whatever's necessary to make the amide. And I'll even draw it this way, NH2. I drew it that way on purpose. Yeah. Yeah, it attacks, the electrons go up, they come back, kick off Cl minus, and then acid base gets rid of the ammonium H. Now remember, in retrosynthesis, you can't just come up with a carbon molecule that's not an alcohol of 4, 5 carbons or less, right? So there's a little reminder here. We do know how to make that amine. Back in chapter 16, we did something called reductive amination. I know it looks like cartoons, right? That would be animation. This is amination, making an amine. Do you guys know what would happen if you put in NH3? I'll tell you what would happen if you put in NH3. Imine, right? How do you make an imine into an amine? What do you have to add to the molecule? Literally, what 2 atoms need to be added to the molecule? Because that's part of your answer if you want. H2. Now, if you're gonna use H2 to reduce a pi, you better have a catalyst too, right? PT, nickel, palladium, rhodium, iridium. There's been some iron catalysts. They're all in an area in the middle of the periodic table. But anyway, PT is our favorite. And they can be mixed together because they will not react with each other. It's not like step 1, step 2. Here, if you made it step 1, step 2, I have no problem with it. You can make the imine and then add the H2. But you can make the imine while the H2 is already there. And right away, it makes the amine. And there you go. And why did I have to show that? Because you had to show me where this set of carbons came from for the finish of your synthesis. Okay? I think that was a good finish.